into any math class you take beyond that, the inequality notation you're used to is kind of going to go away. So you're used to set notation, where you might say -2 is less than or equal to x is less than 4. And that means x is bigger than -2 but smaller than 4. We are going to write this in what's called interval notation. Interval notation does not include the variables, so there's no x or y that we'll see in this notation. What we do is we give a starting point and a stopping point. So -2 to 4, if you think about it on a number line, if you were graphing that, you would have had a closed circle at -2, an open circle at 4, and you would have shaded everything in between. Interval notation says, okay, I'm starting at -2. If it gets an equal to, we use square brackets. So say -2, comma, that's my starting point, then you give your endpoint. Our endpoint is 4. 4 was not equal to, so we use a parenthesis for not equal to. So if I said x is greater than or equal to 7. And so if you think about it on a number line, you would have done a closed circle, and then which way would you have gone? Interval notation, would I start with a bracket or a parenthesis? We always go from left to right. Comma, this goes forever. When something doesn't end, we call that infinity. Infinity is like a sideways 8. Infinity is not an actual number that we can be equal to, so infinity will always get a parenthesis because you can't equal infinity. So if I said x is less than 1, so that would have been an open circle at 1, going to the left. Interval notation, left to right, it's going forever in the negative direction. We call that negative infinity. Comma, where does it stop? And would that get a parenthesis or a bracket? So first thing we're going to do is just practice taking inequalities and writing interval notation for those. So writing inequality using interval notation. You guys think you can try these? Yeah. Okay. Give them a shot and then we'll check. So A equal to means bracket, start at 1, end at 3, both of those had equal to, so 2 brackets. B, let's say -4, comma 0 with parentheses. C, greater than 5 means we're starting at 5, not equal to, so it gets parentheses. Comma, infinity, infinity always gets a parenthesis. And D, what's that one look like? And 1 gets a... Let's go the other way. I'm going to give you the interval. Can you tell me what the inequality was to start with? So what'd you put for A? Good. B?
X is greater than 2.
Good. C?
2 is less than or equal to x is less than or equal to 3.
Good. And D? Alright, so we're good with this notation? Okay. One thing I haven't covered, and maybe I should, if you ever have the entire number line shaded, in the past you always just wrote all real numbers to show the whole number line. If we're doing interval notation, we have to put starting and stopping. What would we say if something's going forever in the negative direction? Comma, if it goes forever in the positive. So instead of all real numbers, we put negative infinity to positive infinity. Alright, let's start solving some inequalities. So solving an inequality is just like solving an equation, except if you multiply or divide by a negative, what happens? Flips the sign. Okay. So if I'm trying to solve for x here, I can subtract my 12x. Divide by -6, which would flip the inequality. So we get x is greater than -4/3. For this section, I'm going to ask you to graph this and give me the interval. So my answer is not the greater than 4/3. What would that be in interval notation?
-4/3 to infinity.
No equal to, so all parentheses. So that's my actual solution. You should be able to draw a graph as well. I am going to be pretty lax on our graphs. So I'm not expecting you to always start at 0 and go whichever way. We just need enough points. So I'm going to say 0. We are going to get away from open and closed circles on our graphs. We're instead going to use parentheses or brackets, just like we do for the interval notation. So this starts at -4/3, so that's like -1 1/3. And instead of putting an open circle, I'm going to put a parenthesis, and then it goes forever in the positive direction. So notice I just curve my parenthesis the direction that my line is going. Let's look at how do you solve a compound inequality like this?
Add 6 to all sides.
And then divide everything by 2. How would we write that in interval notation?
Bracket 3, comma 5 bracket.
Good. In terms of if I asked you for a graph, we have a bracket at 3, bracket at 5. We just put those facing each other and we're dealing with the middle. All right. Is this okay? What if I gave you this one? what would we do first here? Less than, those cancel. Give us 2x minus 1 is less than 0. And then it's like the last problem. So add 1 to everything. Divide by 2. So my solution, how would I write it?
Negative 11, parentheses, negative 11 halves, comma, 1 half, parentheses.
Number line is pretty similar. I'm going to really be lazy on this number line. I'm just going to mark my negative 11 halves and my 1 half. We're starting at negative 11 halves, ending at 1 half, everything had parentheses. Okay, I'm going to give you guys one to try. So subtract 8. What happens now? And what does that do? Okay, and so if you're thinking about this, says x is smaller than 5 but bigger than 9 halves. So you could flip it around. So your actual solution is bracket 9 halves or 4.5, comma 5 with the parenthesis. Interval notation, you always have to go left to right or small to large. Do we need any more examples with our inequalities? So the next thing I want to talk about are quadratic inequalities. Those are going to be a little bit different. We'll see. I'd like to at least get a couple examples of those today. Right, so solving a quadratic inequality is kind of like solving a quadratic equation. So if we had an equals 0 here, what would you do? Start by factoring. Let's do that. Multiply a negative 12, add to negative 1.
Minus 4 plus 3.
Okay, so you would get x equals 4 and negative 3. There are a couple ways of thinking about this from here. I'm going to give you both options. They essentially do the same thing, but then you guys can just kind of tell me what you prefer. Okay. So if you're thinking about a graph, the two places where it hits the x-axis are negative 3 and positive 4. Then before those points, so if I were going to graph it, it hits right here. It was either above or below the axis before we got to negative 3, right? So we have to decide. You can just use what you know about quadratics. Now we haven't really talked about the graph of a quadratic in here yet. So maybe you remember something from last year. What's a quadratic look like? A U. What makes it upside down? A negative. So would this one be upside down? No. We know we're hitting here and here. It should be a normal looking parabola. So it should have looked something like that, right? So before I got to -3, was my graph positive or negative? Positive, because it was above the axis. In between -3 and 4 was negative. After 4, my graph was positive again. You okay with how I got that? I want to know when it is less than 0. So less than 0 would be the negative part. And so I can see my graph was less than 0 everywhere. It was negative. So that was between the -3 and 4. So my answer is parentheses -3, comma 4 with a parenthesis. You can use your graphing calculator. Tomorrow we're going to get into rational functions, things that we don't know the graph of just off the top of our head, so we'll be relying more on that graphing calculator then. But with a quadratic, we do know a little something about the graph, so we should be able to figure it out from there. Do you guys want me to show you another method? I don't want to confuse anybody. The other option is to not do the graph, and then I think this is what the textbook might use if you look in your book. They have you pick test points. So we know those are the 2 times when it hits the axis. So a test point, we need a number smaller than -3. So maybe I could do -4. I need a number in between -3 and 4, so maybe a 0. And then I need a number bigger than 4, so maybe a 5. And we're just going to plug those test points back in here. So if I put in a -4, -4 minus 4, that's still negative. -4 plus 3, is that positive or negative? Negative. And if you multiply a negative and a negative, what do you get? So that tells me every number less than -3 makes this thing positive. If I put in 0, 0 minus 4 is negative, 0 plus 3 is positive, and negative times positive is negative. If I put in a 5, 5 minus 4 is positive, 5 plus 3 is positive. If you multiply 2 positives, you get positive. Which ones did we want? Still the negative, so we get the same thing. So one way is relying on looking at a graph. The other way is just plugging in some test points. What do you guys like out of those 2 options? Plugging in the numbers? Okay. It's my personal favorite, but people usually pick the graphs. So. We agree on something. How about you? Tyler, you didn't voice your opinion. So, what's the first factor? We need this to be something we can easily deal with. So, multiply to -15, add to -2, -5, +3. So the things that make it equal 0 are +5 and -3. So we think about our number line, correct numerical order, so smaller number on the left. So if we want to go ahead and do the test points, we need a number for each interval. So something smaller than -3. something bigger, or between negative 3 and 5. And something bigger than 5. You notice I don't really place those on the number line. I don't put tick marks for them or anything. I'm trying to not confuse myself with my actual points and the made up points that I have. So if I put in a negative 4. Negative 4 minus 5 is negative. Negative 4 plus 3. Negative times a negative. Alright, if I put in a 0. 0 minus 5. 0 plus 3. Negative times positive. If I put in a 6. 6 minus 5. 6 plus 3. Positive times positive. Now we have to decide which ones we wanted. We said less than or equal to, so that means I want the positives or negatives. Equal to tells me what? The brackets. So the bracket negative 3, comma 5. Okay. Let's do one more and then we'll probably stop with those today. Do you guys want to try it yourself? Final answer is a little different on this one. So you had to do slip and slide. Right, so we get x squared is 5x minus 24. So that's x plus 8 minus 3. Divide by 2, x plus 4, 2x minus 3. So if you set those equal to 0, we get negative 4, positive 3x. Okay, test points. Give me something smaller than negative 4. In between negative 4 and 3 halves. And bigger than 3 halves. Okay, so if we put a negative 5 in, negative 5 plus 4 is negative. 2 times negative 5 minus 3 is negative. Negative times negative is positive. We put in a 0. 0 plus 4 is positive. 2 times 0 minus 3 is negative. So that gives us negative. Put in a 2. 4 plus 2 is positive. 2 times 2 minus 3 is positive, so that's positive. We're getting this positive, negative, positive pattern a lot because if you think about a parabola, most of them follow that. But just so you know, it's not always going to be the case. It is possible, especially tomorrow when we do the rational ones, to have 2 positives in a row or 2 negatives in a row. So don't just assume if you know the first one, you can guess at all the others. Could be weird. We wanted greater than 0. So what do we want here? The positives. Okay, so we have to get the interval for this. So this is going forever in the negative direction. So it's a negative infinity, comma, went to negative 4. Was an equal to, so that gets a bracket. With interval notation, when we have more than one piece, we put a U in the middle. It's called a union symbol. And then we put the second piece. So this one started at positive 3 halves and went to infinity. And infinity always gets a parenthesis. Is this okay? Alright. I'm going to stop here today. So tomorrow, I'll probably do 1 or 2 quadratics to jog our memory, and then we'll do the rational inequalities, and that will be the end of this section. So for today's portion,